we're going to have our first instance where we do not have what I call perfect descending order. It has to be that in both the inside and the outside of our division sign, we have to have perfect descending order of degrees. Notice this goes cubic, quadratic, and then we're missing our linear term. There's no x to the 1. And then we have our constant negative 18. That's totally fine. We just have to make sure that we fill the gap. So when I write it, I want to write negative x to the third minus x squared, and then give yourself a gap, negative 18. Out in front, we have our negative x minus the 3. Now the gap is there because I need every degree from the highest down to 0 to make my division work, whether it's long or synthetic division that we're going to learn later. Here, I need to just put a placeholder called a 0x to the 1. And that's my linear term that's missing. I'm just saying there's a 0 there. Putting a 0 times it is effectively 0. As soon as I do that, the rest of the process is exactly the same. I look at the first term inside, first term outside, and I just ask myself, what do I multiply this x on the outside by to get x to the third? And that should be a positive x squared. And then I distribute that to both of these two terms and put the result down below. That should give me a negative x to the third and then a negative 3x squared. And just like elementary school, we need to subtract that value, but different than elementary school, that means we have to distribute a negative sign. So that'll be a positive. This will be a positive, and then I add vertically. First two terms cancel out as by design, and then I have negative x to the second, and then adding 3x squared should give me a 2x squared, and bring down my 0. You can just put plus 0 or 0x or 0x to the 1, doesn't matter, but it needs to be something there, like a 0. So then I go ahead and look at this 2x squared and this negative x, and I ask myself what I multiply the negative x by to get a positive 2x. It's got to be multiplying by a negative 2 and one more x. So then I take that negative 2 and distribute it to both of these terms out in front and bring the result down below. So that should give me a positive 2x squared. And then I take that negative 2 times the negative 3 to get a positive 6x. Then the algorithm is you got to subtract that quantity, also known as distributed negative sign. So that's going to be a negative 2x squared and a negative 6x. Hopefully my ominously large minus sign emphasizes its subtraction here. So I subtract that, and then that's a negative 6x and 0, so it's just negative 6x. And then you go ahead and bring down your negative 18 for the last run through the algorithm. We look at negative 6x, and we ask ourselves what to do to multiply the negative x to get there, and that's just a positive 6 because it's already negative. So then we take that positive 6 and distribute it over here, bring that result down below, and that should give me my negative 6x, and it should give me a negative 18. Those numbers are the same, which means that when I multiply by a negative, distributing my negative there is going to effectively make them opposites. So that'll be positive and positive, so that my remainder is 0, which is excellent. It means that this is a factor. That's r because it's equal to 0. That means that negative x minus 3 is a factor of this polynomial. That wasn't what the question asked. The question just asked what's the result of division. This is the result of division up top. But I can't help, as a math teacher, get excited about the fact that that means that negative x minus 3 times this x squared minus 2x plus 6 is the factored form of negative x to the third minus x squared minus 18. So if I had gone about the business of factoring this, the only business would have been to have done division. And now this is the factored form.